Hello everyone, welcome to Neso Academy. In VHDL, we are required to learn three modeling styles. And among these three modeling styles, we have already studied the first two types, behavioral modeling and structural modeling. And today, we are going to learn the third very important modeling style, data flow modeling. So, our today's topic is data flow modeling. Now, data flow modeling is considered the simplest modeling style among all three modelings because to implement a circuit in VHDL through data flow modeling, we can directly use Boolean expressions. Therefore, data flow modeling is very popular for designing combinational circuits and simple logical designs. Now, let us understand what is a data flow modeling using the same circuit of the half adder. Now, the question comes that what is a data flow in data flow modeling? Now, to understand this, focus on the circuit diagram of the half adder. Here we have two inputs, A and B, and this half adder is generating two outputs, sum and carry. Now here we can see that inputs A and B are moving through the logic gates XOR gate and AND gate. And this XOR gate is generating output sum and this AND gate is generating output carry. So here we can see that the flow of data from inputs to the outputs via the logic gates. And the same thing we describe in data flow modeling using the Boolean equations with the help of logical operators. Meaning, here we can see that output sum is equal to A XOR B and output carry is equal to A and B. Now, using these two Boolean expressions, we can clearly see that there is a flow of data from inputs A and B to the outputs sum and carry via the logic gates XOR gate and AND gate. Therefore, we call this modeling style as data flow modeling. And I hope you understand this. Now, let us quickly see the VHDL code for this half adder using data flow modeling. Now, the code starts with library declaration. Here we have library IEEE. Then comes standard logic package from this IEEE library. Now, after library declaration, what comes next? Entity declaration. So, inside the entity, we will declare the input and output ports. Entity starts with the keyword entity, and here I am naming this entity as half underscore adder because we are writing the VHDL code for this half adder. Entity half adder is after the keyword port and inside the parenthesis, we will declare the input ports and output ports. Here we have two inputs A and B. So here I am writing A and B as in standard logic. We have two output ports, sum and carry. So here I am writing sum carry as out standard logic. Now we are done with the inputs and outputs, and both inputs and outputs are of standard logic data type. After port declaration, we can simply end this entity using the keyword end and the name of the entity half underscore adder. Now, entity declaration is complete. After entity, we have architecture. Inside the architecture, we will describe this half adder using data flow modeling code. Now, the architecture starts with the keyword architecture, and I am naming this architecture as data flow because in this architecture, we will write data flow modeling code. Architecture data flow of entity half underscore adder is. Now, inside the architecture, after the keyword begin, we can write the Boolean expressions for this data flow modeling code. Now, here we have two Boolean expressions. sum and carry, which are representing the two outputs sum and carry. Now let's see the Boolean expressions. Here sum is assigned A XOR B and carry is assigned A and B. Now here we can clearly see the flow of data from inputs A and B to the output sum and carry via the logical gates, XOR gate and AND gate. So, in data flow modeling, we can simply write the Boolean expressions. And also, I hope you remember that we have already discussed that in data flow modeling, we use concurrent statements, meaning both of these expressions will execute simultaneously at the same time. Now, after the Boolean expressions, we can simply end this architecture using the keyword end and the name of the architecture data flow. So, I hope you understand this VHDL code for data flow modeling. Now, this time we will implement this data flow modeling VHDL code in Vivado. But before that, let me quickly summarize what we have discussed till now. Data flow modeling uses Boolean equations and concurrent signal assignments. In data flow modeling, we use Boolean equations using logical operators. And in data flow modeling, each and every Boolean expression execute at the same time, that is, in parallel. So, data flow modeling uses Boolean equations and concurrent signal assignments. Now, data flow modeling focuses on how data moves from input to output through logic operations. And here we can clearly see that in data flow modeling, we describe the flow of data from inputs to the outputs via the logical operators. Now, I hope you understand these 2 points. Let us quickly see few advantages and few disadvantages of data flow modeling. Starting with advantage. The first advantage is data flow modeling uses simple and compact code, making combinational circuits easy to design. Now in data flow modeling, we use simple and crisp code using logical operations, which makes code easy to understand, which makes code easy to design. Second advantage is Boolean equations can be written directly, making the logic easy to understand. In data flow modeling, we directly write the Boolean equations using the logical operators for our circuit, which makes code easy to understand and easy to implement through VHDL. So, these are the advantages for data flow modeling. Now, let's see a disadvantage of it. Data flow modeling is not suitable for designing large and complex sequential systems. Now, in complex sequential systems, we may have thousands or even millions of logic gates. Now, deriving Boolean expressions for such circuit is extremely time consuming. Instead, we can use other modeling styles that can easily describe the behavior of such complex circuits. So, data flow modeling is not suitable for designing complex sequential systems. So, this is the disadvantage of data flow modeling. Now, we are all set to implement our data flow modeling VHDL code in Vivado that we have already installed in our previous lectures. Now, we are in my computer system and I have opened Vivado. And this is our VHDL code editor of Vivado. And here I have written the same data flow modeling code for the half adder that we have seen in the presentation. Starting with IEEE library, then we have entity declaration. Inside the entity, we have declared the inputs A and B and the outputs sum and carry. Then we have the architecture, data flow. Inside the architecture, we have written the Boolean expressions, where sum is assigned A XOR B and carry is assigned A and B. So this is the same VHDL code that we have seen in the presentation. Now, let's see the schematic diagram generated by Vivado for this VHDL code. Now, there are certain steps to generate this schematic diagram that we will understand in upcoming lectures. Here, I have already generated this schematic. Let me show you. So, this is our schematic diagram for the half adder using Dataflow modeling. Here we have two inputs A and B, two outputs sum and carry. And here we can clearly see sum is equal to A XOR B and carry is equal to A and B. So, the Boolean expressions are directly converted into the schematic diagram. Now we have seen the VHDL code, we have seen the schematic diagram. Now let us see the simulation waveforms generated by Vivado to verify our code. Again, there are certain steps to generate these simulations that we will understand in upcoming lectures. Now let me quickly show you the simulations. So, this is our simulation waveform window. Here we have two inputs A, B and two outputs sum and carry. Now, in the half adder, we have four input combinations. Let us verify one of the combinations here. Let's take A as 1 and B as 1. For that, right-click on signal A, select force constant. The value radix, let it be hexadecimal. Assign a force value 1, then click on OK. Similarly, right-click on signal B, select force constant and assign a force value 1, then click on OK. So here we have assigned the inputs A as 1 and B as 1. Let me run this simulation for 100 nanoseconds. For that, click on Run for 100 nanoseconds. Now our waveform is generated. Let me maximize this waveform. So here we can clearly see A is equal to 1, B is equal to 1. And when both inputs are high, then sum is equal to 0, which is correct, and carry is equal to 1, which is correct. So, this is the simulation waveform generated by Vivado. And I hope you understand how to implement the data flow modeling code for the half adder in Vivado. So, I hope you understand what is a data flow modeling and how to implement a data flow modeling code in Vivado using VHDL. With that, we are done with this topic of data flow modeling, which means we are done with this lecture. I will see you in the next one. Thank you.